actually one of my mentors also when I was doing my studies in Delaware. So it's been around for a while. We're going to change tacks a little bit. We're still talking about nitrogen use efficiency, but we're going to talk about nitrogen fertilizer enhancers. There's a lot of interest in this. I can't count the number of phone calls I get about things like Eurasian, Agrotane, and all of these products that are out there in the market. So instead of me standing up here to talk about who we're good, the horse's mouth Greg's done a lot of work with these products, and we'll let him take it from there.
All right, Josh. My voice tends to carry pretty loudly, so everybody hear me okay without a microphone? What's that? I mean, I can stand back here, but I really hate to stand still. So, Josh had said I was asked to talk about some of these new technologies that are available for us in nitrogen management when we're managing nitrogen in corn and other crops, primarily corn here in this region. All of us have seen the nitrogen cycle, a very complicated cycle. We know that nitrogen can change its forms rapidly out in the environment. It can easily get away from us. And the idea is that these products are designed to try to keep nitrogen where it belongs, to keep it in the field and reduce that potential for loss. I find often that as I talk about these things, I give just a little bit of an overview just to make sure that we're all on the same page, okay? And most of you are going to be well aware of this, but when you look at nitrogen in soils, there's three major forms. One is organic nitrogen, okay? So nitrogen is in soil organic matter, it's in old plant residues, and obviously animal manures that have been applied to the soil. And then our two inorganic forms are ammonium and nitrate, okay? And when we add fertilizers to the soil, obviously we're adding products that are in the ammonium or nitrate form. And as we know, ammonium does not tend to stay around in warm soils. What happens to it? It nitrifies and converts over to nitrate. Okay, we kind of like to be able to keep it in that ammonium form because of that positive charge ion, or positive charge on the ion, would help keep it in the soil and help reduce the chance of it leaching away from us. Okay? Now, why does this convert over to nitrate? As we know, it's because of nitrification. All right, nitrification is its conversion of ammonium to nitrate. Simplifying the equation here, ammonium ions combine with oxygen and convert over to nitrate. All right, it's a fairly rapid process in warm soil. The biological process is controlled by microorganisms, and it's also a temperature-dependent process. It's going to occur a lot faster in May than it is in March. Nitrification is insignificant below about 50 degrees. Now, how fast does this conversion occur? I pulled out some data that I collected several years ago, where we went out in about April 10th, and we put down ammonium sulfate fertilizer. Okay? Ammonium sulfate, all of our nitrogen would have been in the ammonium form. We came back in late May, when the corn was about 8 inches tall, and we took soil samples. And this is just data from the top 6 inches. Broken down, you see ammonium and nitrate. So the green bars are ammonium. We had 3 different rates of nitrogen, 50, 100, 150 pounds of acre. And what you see is that everything is nitrified over. We're about 5 parts per million ammonium for all 3 rates. Everything is converted over to nitrate. So it's a process that doesn't occur immediately, but within a few weeks, you're going to convert most of that ammonium over to nitrate. And that's the form that can get away from us. So one of the technologies that's out there, and this has been around for many years. When I was in graduate school in the mid-'80s, there was a tremendous amount of work going on with a product called nitropyrin. The commercial name was Insert. All right, it's a nitrification inhibitor. And when you look at these technologies, people talk about different stabilizers. It's important to know what is that technology that they're using. Is it a Eurasian inhibitor? Is it a nitrification inhibitor? Because there are products that do they work differently. Nitrification inhibitor is designed to slow the conversion of ammonium to nitrate. It basically stops this reaction. It kills the microorganisms that are responsible for converting ammonium over to nitrate. All right? It doesn't kill them forever. It just kills them for a time being, and then in a warm soil, those microorganisms come come back, and that nitrogen will eventually nitrify over to nitrate. When I was working with insert back in the mid-'80s, I showed you that data a minute ago where everything had converted over to ammonia by late May. On our insert plots, it had not. It would work. It would keep the product in the ammonium form. Okay? So thereby it should reduce the loss potential of that product. Problem is that there were some studies that showed benefit from this, but most of the studies you never ended up with a yield benefit at the end of the year. Okay? But when you look at today's fertilizer market, it's a lot different than it was back in the mid-'80s, when nitrogen was 10 cents a pound. Okay, now we're talking 50, 60 cents a pound, and I hear even higher possibly for this coming year. So you look at these products, and I think the potential benefit is much greater when we're talking about a product that costs much more than it used to, actually just 4 or 5 years ago. But and the other thing to keep in mind is that the potential value of these products increases with the length of time between application and plant uptake. Okay, if you're going out and side dressing corn and putting that nitrogen on just before that plant needs it, the potential value of that product is a lot less than if you're going out and putting it on 2 months before the plant is going to need it. Or what they do in the Midwest, they go out and put anhydrous on in the fall. In that situation, they typically use a nitrification inhibitor because they've got several months before the product is going to be, or before that nitrogen is going to be needed. Okay, so it's important to keep that in mind too. So when we look at nitrogen loss, there's 3 major ways that nitrogen is lost, and this is a review again. We're talking about leaching, denitrification, and volatilization. Okay, so when we're trying, products that are nitrification inhibitors are trying to reduce leaching and denitrification. They're trying to keep that ammonium or that nitrogen in the ammonium form. Okay, products that are, there's some, I'm going to talk about a slow release polymer coated urea product. The idea here is you're actually trying to do all 3 of these. You're trying to reduce leaching, denitrification, and volatilization. All right, sometimes people get confused, I find, about denitrification and volatilization. 2 completely different processes. All right, leaching, fairly obvious. Nitrate moves down through the soil as water moves through. Denitrification is when you have nitrate out in that soil and under waterlogged conditions, lack of oxygen. When there's no oxygen in the soil, the oxygen is stripped off of that nitrate molecule and the nitrogen goes up as a gas. Volatilization is a completely different process. All right? Volatilization, what is the major form of nitrogen that's lost through volatilization? All right, it's the ammonium ion. Whenever we have ammonium in a high pH environment, it will tend to volatilize. All right, and so soil pH is a major influence on ammonium volatilization. And it's simply a chemical reaction. This is a chemical reaction. Ammonium wants to convert over to ammonia gas. All right, this equation is in equilibrium at a pH of 9.3. So in other words, if you had a closed environment, you put ammonium ions into that environment and let it sit for a while, you would basically, and you had it at 9.3, half of your nitrogen would be ammonia gas, half would be ammonium. Okay? So volatilization is strictly driven by this reaction. As the pH goes up, that reaction is pushed this way. That ammonium converts to ammonia gas, which if it's on the soil surface, it's going to get away from it. Factors that affect volatilization. One of them is the cation exchange capacity of the soil. Okay? A higher cation exchange capacity soil is going to compete more with those ammonium ions. So you won't get as much volatilization on a high CEC soil as you will a low CEC soil. Wind is going to have an impact. Okay? Obviously, out in the soil, we're not in a closed environment. So you get a situation where little ammonia is coming off the soil surface. The wind comes along and blows it away. More ammonia wants to be produced. Okay? And then it's also temperature dependent. Temperature drives this reaction. This is some data that I pulled out of a study that was published back 20 years ago, showing the impact of volatilization on at different temperatures. Okay? Down here, this is days since urea fertilizer was put on, 0 to 10 days. Okay, here we are, 45 degrees, 60 degrees, 75, 90 degrees. Okay? So you see the effect of that temperature. That's important to understand because if you're looking at a product that's designed to prevent urea or ammonia volatilization, it's going to have much greater potential value in the middle of May than it is in the middle of March. Okay? And then how do we prevent ammonium volatilization? By incorporation, by getting it down into the soil. We mix that ammonium into the soil, or we wash it down into the soil, Mother Nature, or irrigation water. Usually about half an inch of rain is enough to get it into the soil surface. Okay, now, I said that our ammonium volatilization occurs when you have ammonium ions in a high pH environment. Okay? Now, our soils in this part of the country aren't a high pH. All right? So there's really only two situations where we have to worry about ammonium volatilization. And those are where we have animal manures and urea applied to the soil. Okay? Why is that? Well, animal manures tend to have a higher pH. All right? And you get volatilization in it. And then with urea actually is a synthetic. Actually, some people call it technically an organic compound because it's bound to carbon. Actually, that must be the next slide. Anyway, it's broken down, and as that product breaks down, it converts to, it's hydrolyzed by urease enzyme. As it does this, the first breakdown product is ammonium carbonate. Okay? That ammonium carbonate, what do you think that carbonate does? What do we use calcium carbonate for? We use calcium carbonate to increase pH, right? And if we don't, it's not because of the calcium, it's because of the carbonate. That ammonium carbonate, that carbonate causes the pH to go up around that urea prill. All right? It's not something you can go, you put urea on, go out and measure the soil, take a soil test and see a high pH. But if you go in and measure around that urea prill, like this individual did many years ago, he went in and measured the pH around that urea prill. 3 days after application, 7 days after application. Okay, 8 millimeters, about a third of an inch. 25 millimeters, about an inch. Okay, look at this pH around that urea prill. And even out here 7 days, an inch away, we've raised that pH around that prill simply because of the way the product breaks down. So now we've got ammonium in a high pH environment, and it wants to blow off if it's sitting on the soil surface. Okay? And here's just a table that I pulled out for another presentation. It just shows the relationship of ammonia to ammonium at different pHs. Okay? So it's a logarithmic scale. It's 9.3 I was talking about, B50. So that brings us to urease inhibitors. Okay? Urease inhibitors are simply a material that's designed to shut off the urease enzyme. Urease enzyme is prevalent throughout the environment and in soils. Okay, so that urease comes along. This is the molecule for urea. Breaks down that urea molecule, forms ammonium carbonate. You now have that ammonium ion sitting in a high pH environment, and you've got that potential for ammonia to be converted to ammonia gas. Okay, so a urease inhibitor is designed just simply to keep that nitrogen in the urea form. Okay? Now, if we can keep it in the urea form and then get it down into the soil while it's still in the urea form, then as it hydrolyzes, it's in the soil and it's captured by the soil water and doesn't escape on it. Okay? So that's what a urease inhibitor is designed to do. It's not designed to stop nitrification. It's just designed to prevent urea from being converted over to shut down that urease enzyme long enough to get that urea down into the soil. So if you look at the potential of a urease inhibitor in terms of the potential value, the greatest value is going to be where you have urea broadcast on a soil surface. Okay? You've got lots of fertilizer, and there's lots of soil to fertilizer contact, okay? And all of it is out there as urea. The second greatest potential would be as UAN. UAN, you've only got about half of that product as urea. The other half is ammonium nitrate, okay? So you're worried about that urea portion, okay? And then the third place is in a durable band, Okay, we put up nitrogen on, or urea, UAN on in a dribble band, simply because we're trying to reduce that fertilizer to soil contact. Keeping it in that dribble band greatly reduces the amount of volatilization. Okay? Doesn't completely eliminate it, but it greatly reduces it. So again, if you're rating the potential response for a Eurasian inhibitor, that's what I'm trying to do there. As I already said, if we can get that urea down into the soil, we can prevent Eurasian inhibitor from occurring. Or urea, we can prevent ammonium volatilization is what I try to say. Okay, now with that background, let's talk about some of the new products that are available. One product that's available on the market is called ESN. ESN is manufactured by Ammonium Corporation. I think it stands for Environmentally Sensitive Nitrogen. But it's a polymer-coated urea fertilizer. It's a technology that's not new. There were polymer-coated urea fertilizers that have been around for many, many years. The difference is that the technology that they're using to do this, typically this technology has been too expensive for row crops. Okay? They've developed a technology where they've been able to reduce the cost, and they are actually developing a product that's designed. I can tell you that the company is trying to develop a product that fits in the corn market of the Midwest. All right, that's what they're looking at this product to do. They've asked me to do some testing with it out in this environment because they wanted to see how it works under extreme leaching conditions, understanding soil. So I've been working with this product for a few years. Agrotane. Agrotane is a chemical that's a urease inhibitor, and it's marketed by Agrotane International. Agrotane International has been around for, I think, since about 2000. The chemical Agrotane, NBPT, has been around since the 70s. You can go back and find research on NBPT in the 70s, which is a urease inhibitor. Agrotane simply picked up that product and has started to market as a commercial name called Agrotane. They also have a product called Agrotane Plus. I think this is a fairly new product, but it's called Agrotane Plus, and it is actually a combination. It's supposed to be a urease inhibitor and also a nitrification inhibitor, so it's doing two things. Okay? Then there's a product called Super U, also marketed by Agrotane. All three of these products are marketed by Agrotane. Super U, okay, Agrotane Plus is designed for UAN solution. Super U is basically they've taken urea fertilizer and mixed it together with Agrotane Plus and then reformulated urea pearl, and they call it Super U. So it's urea that has your urease and your nitrification inhibitor mixed together in the product. Okay? And then there's the newest product, and actually these products, as I said, the first four, well, this technology's been around for a long time, but all of these have been around for a while, but they're relatively new now in terms of being used in the ag market. A brand new product that as far as I know, hasn't been around at all until it came on the market last year is a product called Nutrisphere. Nutrisphere N, the acronym that's often associated with it is NSN. This is marketed as a urease inhibitor and a nitrification inhibitor. Okay? So I started working with ESN several years ago, just in the last couple of years, because we were doing this nitrogen work and there was a lot of questions that were coming about. We started incorporating the Agrotane and Nutrisphere into some of our studies. I'm going to start off and talk about our ESN studies. First of all, if you look at ESN, ESN is it's a polymer-coated product that is designed to it's designed to take in water, and it basically forms a urea solution in that krill, and then that polymer opens up, pores in that polymer open up as the temperature goes up. Okay? So it's temperature dependent, and this just shows breakdown. ESN polymer, or ESN krills that are put in water at different temperatures. And you can see the effect of temperature. Okay? Here's 5 degrees Celsius, 10 degrees Celsius, 23 degrees Celsius. And the idea of the product is that they're trying to, as I told you, this is really designed, they're trying to go after the corn market in the Midwest. They're trying to emulate the growth response curve, or growth response curve of corn. Okay? That's their goal. Some data that came by Rich Coney out of Washington State University, where he was looking at volatilization. Okay? Volatilization of this product. He had a control where they didn't have any fertilizer. 0 to 3 days, all the way up to 16 to 19 days. Okay? And you can see there was no volatilization for the control. The green bars are the ESN, the red bars are urea. Okay? As you'd expect, a lot of volatilization with the urea. Now, it makes sense that this product would not have that much volatilization because it's only putting that urea solution out at a slow rate. Okay? It's not like urea where it's all out there at one time. So your concentration of urea in contact with the soil at a given time is greatly reduced. And so you don't tend to see volatilization from that product. They've also got some data that collected from a researcher at Ohio State University on leaching. The idea, again, that product's going to come out of that polymer slowly, and you don't have as great a leaching potential. Here's a study they did in lysimeters with winter wheat. There's your control. Okay? A little bit of leaching going on. Here's UAN at 45 pounds per the acre. Here's urea at 45 pounds per the acre. Okay, this is just over time. Down here at the bottom is just rainfall amount. All right? So you can see there's a big leaching event that occurred right in here before that wheat was really actively growing. It's interesting, I think, too. Well, let's look at the rest of these. There's ESN at 30 and at 45 pounds per the acre. So they saw less leaching, which makes sense because, again, that nitrogen coming out of that polymer slowly. Interesting that once that crop is really growing, you're not seeing any leaching events, even though there's some significant rainfall going on it in that soil, or at that site, I should say. All right, now, move into some of the data that we've been collecting in Delaware. This is irrigated corn in 2000. Can anybody remember back in 2000? Tell me what was significant about the year 2003. We almost washed away. We had the wettest year in over 100 years. It was extremely wet in 2003. In 2002, I didn't show the data here, but I went out and put nitrogen on at 120 pounds, and I didn't get any differences in any of my products. Come to find out, that site had nitrate in the irrigation water. Okay, so we weren't seeing any differences in our product. I came back to that site the next year, and I reduced our nitrogen rates down, or I said 120, it was 180. I reduced our nitrogen rates down to 150. Can't really see this, but we put 150 pounds of nitrogen on. Okay, and we looked at pre-plant versus side dress. And our goal, I should point this out, when we started this, the question that was out there that they wanted us to address is, how does ESN put on in a pre-plant situation compared to what we consider our standard practice in Delaware of putting on a small amount of nitrogen, 30 to 40 pounds early, and then coming back and side dressing? Okay, could we do the same with that product? Okay, so in 2003 we had this is 150 pounds of nitrogen. This is UAN. Actually, this is urea. Pre-plant was urea. This is urea. This is ESN. Okay, there was a significant increase in yield with ESN, but look at the yields. The yield levels were extremely low. That corn was actually showing nitrogen deficiency by the time it was about this tall. All right, and that's why we side dressed. Okay, we had an extreme leaching year, and 150 pounds of nitrogen. We had corn this tall that was already showing nitrogen stress because this was an extremely sandy soil. All right, let's compare what we did with side dress. Okay, even our side dress plots this year were stressed from nitrogen because we didn't irrigate that much. But we saw a significant difference between the ESN and the side dress. Okay, now with this ESN in this situation, this is a dry fertilizer, so we spread it on and then incorporate it with a row cultivator. Okay, which not too many people are row cultivating these days. But anyway, the question of does ESN do better than our standard practice? No, not even close in 2003. All right, let's move on. 2004, same study. Okay, pre-plant, side dress. All right, we didn't have nearly as bad a situation. These differences were statistically significant, but again, our ESN did not outperform our standard of side dressing. okay, with UAN. All right? ESN was better if you're just looking at pre-plant in, but it didn't do better than our side dress application. Okay, I actually said this is the next year. This was actually in the northern part of Delaware. I apologize. Got ahead of myself. This is a silt loam soil. This was in northern Delaware in 2003. And this was not, none of this was incorporated because this was a no-till field. All right, now moving on, 2005. We didn't work with it 2004. 2005, urea pre-plant, ESN pre-plant. Okay, pretty big yield differences. But then when we look at our side grass, again, our side grass, our standard, what we would call our best management practice is not better than ESN. Okay, and no difference in this situation with the two products at side dressing time. Now, I started a different study in 2005, and it was looking at some different timings. But this was, the orange bar is, we put on 170 pounds of nitrogen in this study, okay? That orange bar, this is ESN means we put on ESN, all of it on pre-plant. And then the /0 means that we didn't side dress at all on that plot, okay? This plot, 100% urea, pre-plant, no side dress. Okay, look at the difference that we got between those two products. The blue bars were actually a 50-50 split. All right, we put on half the nitrogen early and then half the nitrogen in side dress. And this is ammonium nitrate split with UAN. This is ESN split with ESN. And this is ESN split with UAN side dress. Okay? And then our final treatment was our standard UAN. Okay? Now, you see that our yields actually, this was actually our best yielding product in that year. Okay? And this, I don't remember if this is significant or not, 150, it's not significant, but I think this may be a real trend. Why do I say that? Because in 2005, we had a tremendous time trying to get out and side dress. It kept raining every time we wanted to side dress, and our corn was actually turning really yellow and nitrogen deficient, where we put on our, this was the colors aren't coming out right here, but this was 30 pounds early with the planter, and then 150 pounds of side dress. That 30 pounds early wasn't enough to keep the corn going when we kept getting rain when that side dressing time. So these products looked a lot better than this did, and I think we might have hurt our yield potential slightly there. But this is an anomaly, okay? I've had this happen only one time where that ESN product was actually a little bit better than side dressing. This is one of the issues that we have. You notice this ESN split with ESN. If you're putting ESN on before you plant, you can come in and till that. And if you're in a no-till environment, you put ESN on, and it'll tend to stay put. But this product tends to float with water. And so if you go in and put ESN on a bare soil, what we find is it'll move around on you. See these pockets? Okay? So that's actually the company doesn't recommend using it in that situation because it really does move around significantly if there's no residue out there. Okay, 2006, that same study we just looked at, you can see our best treatment was our what I call our Delaware standard, side dress. Okay, so we certainly didn't get that improvement this year, but we did see a big difference between urea put on pre-plant. Okay, so you know, when you look at this product, at least in corn, let's go ahead and look at 2000. These are 3 more sites I have in 2006. This was where we put on we put on 120 pounds early. The farmer put on anywhere from 30 to 50 pounds with his planter. Then we put on 120 pounds before the corn came up. This was a split, 60 pre-plant and 60 side dress. And then this bar was everything went on side dress. And you can see this was a Pocomoke soil in southern Delaware. And we really didn't have a huge significant, I wouldn't call it that wet of a year. But you had a big yield hit by putting that ESN all on pre-plant. So a general recommendation with this product is on sandy soils that you don't want to go out and put ESN on and have that be your total nitrogen program early. It's just, it can, even though it's a polymer, and it's obviously, you know, you look at this data shows it's obviously holding the nitrogen. It's not holding it at the same rate as side dressing. Okay? Now, if you're in a situation, and there are situations in the northern part of our state, and I know you have them in Maryland, where you're putting all your nitrogen on pre-plant. If you're putting all your nitrogen on pre-plant, this is the product that I think is worth at least taking a look at. I wouldn't go out and change everything over, but I would definitely go out and take a look at it, because we do see significant differences in this product versus a regular soluble product that's put on pre-plant. Okay, moving on to winter wheat. Winter wheat, we've actually done, we've been doing strip trials that are about 400 feet long. And we go out and compare different products. When I started in 2005, we were just looking at ESN. Actually, in 2004, we just looked at ESN, 100% ESN. Come in, put that on when the wheat was just getting into green up. And what we found is that during grain fill, the ESN strips were yellow relative to where we use regular UAN. And it's simply because we put that on a cold soil and you put it on top of the soil, it's not mixed into the soil, it was not breaking down fast enough. So then we started looking at, all right, what happens if we mix it with a soluble form of nitrogen? All right? So what we did, ESN 70 means that 70% of that product was ESN, 30% was ammonium nitrate. Okay? And I did a couple studies with ammonium sulfate, and this one was ammonium nitrate. All right, ESN, and this was 50-50. This is 30% ESN, 70% UAN, or 70% ammonium nitrate. And then we had a UAN treatment. Okay, these all went on to green up. And what you see down here are statistics. Okay, if it's the same letter, that means there's no significant difference. So the only significant difference that we got here was the ESN 70. All right, the ESN 70 obviously is still too much of the product is ESN. It's not releasing fast enough. Okay, but the ESN 30 has consistently looked pretty good. That's usually the best mixture, somewhere around 30, at the most 50%. This was in 2006, a very high yielding site. I dropped out the ESN 70 because it was obvious that that was still too much. So ESN 50, ESN 30, and then UAN. All right? Statistically, this was actually better than the UAN. Now, in 2007 was when we started getting questions about all these new products. So, it changed the study slightly. We went out and we put down 4 rates of UAN to get an idea of what the nitrogen response was. And then we looked at Agrotane, Agrotane Plus, Nutrisphere nitrogen, polymer-coated urea, which actually should say ESN, and ammonium nitrate or urea. Okay? And if you look at our first site in Sussex County in 2007, this shows we put on 4 different rates of N. All right? And my goal here is to not, these are big strip plots, and growers don't like to have big strip plots with no nitrogen. So I'm trying to get on that response, this part of the response curve. And you can see that we hit it just perfect. All right, this was 80 pounds of N. This site in 2007 had no nitrogen put on in the fall. 80 pounds of N, 78 bushels, 88 bushels with 95 pounds of N, and then 97 bushels with 110, 98 bushels with 125. So we had our response, just the way I wanted it, and this is the rate where we compared all the products. Okay, so we were on that responsive part of the curve. All right? So now, if we come in and look at each of these products, this is our UAN. All right? Here is UAN with Agrotane. This is UAN with Agrotane Plus. This is UAN with Nutrisphere. This is that ESN 50-50 mix. This is where we have 30% is ESN, and this is ammonium nitrate. Okay, so the only thing that was significantly different of the products was ammonium nitrate. All right, no differences across these different products. Now, when I look at 2007, actually, let's look at one more site reduced the rate slightly because I didn't think the yield potential was as good. But 71, 76, up to 90. So we definitely got that. We're definitely on a yield response. Again, the blue bar is where we did the comparison. We look at the products, UAN with Agrotane, Agrotane Plus, Nutrisphere, ESN 50, ESN 30, and ammonium nitrate. Okay? So none of these were different. Again, this was significantly higher, but most of that is probably coming from the ammonium nitrate. We're getting a little bit of a kick there, but most of that's probably coming from the ammonium nitrate. Now, 2007. When I looked at the growing season of 2007, except for one rainfall event, we really didn't have a lot of potential, I would say, for losses. Okay, we had one event in early April where I think we could have had losses, but it wasn't significant. It wasn't a real high loss potential. 2008. This brings us to 2008. 2008 was, I think we had conditions where we should have lost nitrogen. We had a lot of rain in March and April. Matter of fact, when we were trying to put these nitrogen treatments on, we had a hard time trying to get out there to put them on because it kept raining. I was telling the guys, I want to put these on and let them sit for a few days, trying to get some volatilization potential. Well, we put the products on and it rained either that night or the next night. But we had to get them on because it was getting stretched. But what you see in 2008, this is a different farm, but we got higher yields than we had in 2007, but we didn't have as big of a nitrogen response. Okay? That's not nearly as big a response. We had about a 20 bushel response the previous year. But again, comparing the products, UAN with Agrotane, Agrotane Plus, Nutrisphere, ESN 50, ESN 30, and ammonium nitrate. This is a little confusing. You got to think about all these letters. Okay? Anything with the same letter is not significantly different. So really, the only thing that's significantly different is this is significantly different from those two. Doesn't really make a lot of sense. I can't explain why why would Agrotane Plus actually have a little less yield than Agrotane? Are we really looking at true differences there? Or is it this variability is going on? I mean, the differences aren't that great. We go to the next site. This was also in Sussex County. They had a little bit more of a response, but statistically there were no differences in any of the products. So, these products were a little bit different at this site. Point that out. This is urea as our standard. Urea with Agrotane, Super U, urea with Nutrisphere, ESN 30, this is ESN 30 with urea and with ammonium nitrate, and then that's straight ammonium nitrate. Keep in mind it rained within 2 days after putting this on, so Eurasian inhibitors really should be, they're going to be wiped out. But anything that's having a nitrification inhibitor effect, we had a lot of loss potential, I think. But we didn't see any differences. I mean, our standard urea treatment was the best thing out there. Okay. Talk a little bit about Agrotane. There's been a lot of work done with Agrotane. Oh, good. I still have a half hour. We've got about 150 more slides. So. All right, I'm kidding you all. But I am supposed to go to 3:30, right? All right, so there's a lot of work that's been done with Agrotane. So I pulled out some of this work since that was the goal of this presentation. And this is work out of University of Kentucky and University of Illinois. Steve Eaglehart, who does a lot of nitrogen work. And this is simply measuring ammonia loss, okay? And this actually has ESN and Agrotane in it, okay? This MBPT is what I mentioned earlier. It's been around for 20, 30 years, and that is the chemical that Agrotane is, okay? So this is just urea with Agrotane. If we look at volatilization of urea, this is what we saw. And keep in mind that these studies that measure loss are really not something, what you want to focus on is the differences in the product, not the total amount of volatilization, okay? The differences in the products are certainly relative. There's UAN. If we put urea on with Agrotane, incidentally, usually Agrotane has two recommended rates. They have a rate of a 7-day rate and they have a 14-day rate. The idea is how many days do you think your nitrogen is going to be sitting on the soil surface before it rains on it and gets it down into the soil, okay? So this study, they use a 7-day rate, and their data supports that. You can see here at 7 days, they weren't getting any volatilization when they were using urea with agrotane. But then it starts to volatilize because they only have 7-day rate on. UAN with agrotane, same thing. No volatilization up to about 7 days, and then you start to see volatilization. A couple of other different products that I'm not even familiar with, and then ESN, they also had in this study. Supported the work out of Washington, which shows that you have greatly reduced volatilization potential with ESN sitting on the soil surface. Okay? Now, this goes back, these bars are supposed to come in one at a time. It's not working right. Okay? It's all right. Confuses me though. This is a study, this is a 3-year summary of work done by Dick Fox at Penn State University. Did a tremendous amount of nitrogen work during his career. And what I pulled this out of a journal article a couple years ago for another talk that I was giving. But this is the average of 100 and 150 pounds of N, because there was no interaction between that and the product that we were looking at. But this is urea broadcast without agrotane. Had an average yield of 97 bushels. If they put on agrotane, they got almost a 20 bushel response. Okay, again, 3 years of data across 2 rates of N. And then ammonium nitrate was another factor that they had in here, yielded close to the urea with agrotane. Okay, my point here, again, what I'm trying to do is just to show you the technology and where it may have its best fit. Okay, this is a study out of Illinois. This graph is confusing, so don't start digging into this graph. Come along with me here. Okay, the first thing I want to do is take a look at urea broadcast on the soil surface. This is pre-plant no-till corn. This is a summary of 8 site years. Okay, inside this box we're comparing urea to urea with agrotane. Okay, and this is the yield benefit. So that's, in other words, compared to control. We're not putting on any nitrogen. This is how much yield response they got by putting on urea. This is the yield response they got from putting on urea with agrotane. They convert that to an economic response, and this is in 2004. So I'm sure that wasn't using today's corn value. But what they saw was a $42 per acre value from using agrotane in this situation. Again, summary of 8 site years. Okay? Now, UAN shouldn't have as much volatilization potential because only half the product out there is urea. UAN broadcast without agrotane, UAN broadcast with agrotane. Okay, it's pretty close to break even. A little bit of a benefit of paid for the product. Again, this is based on 2004 values, so it might have a little bit more value using today's corn prices. Then they compared UAN in a dribble band. Okay? Dribble band without agrotane, dribble band with agrotane. Okay? In that situation, it was not an economical investment in buying agrotane on average across the base cycle. Okay? And then there's some other products that they tested. Incidentally, this is UAN injected. So you're seeing a benefit there compared to dribbling. But the goal here was to look at agrotane results. Okay. Finally, I want to take you to some work that I just came across out of the South. And this is actually work that was done with rice. Okay? And you might say, why in the heck are we talking about rice in Maryland, on the eastern shore of Maryland or in the state of Maryland? And keep in mind here, I'm not trying to show rice results. What I'm trying to show you is technology. Okay? In a rice environment, they have a tremendous potential for volatilization. Okay? So in this study, this is actually Dr. Rick Norman with the University of Arkansas. He was looking at urea, agrotane, ammonium sulfate, and then a urea ammonium sulfate blend. Okay? Again, reducing your volatilization simply because you don't have as much nitrogen out there as urea. 3 different rates of N. And then they put this nitrogen on these fields, and then they come in and flood the field. And it can take them anywhere from a day to more likely 5, 6, 7 days, and sometimes a little bit longer before they can come in and flood the field. So if they're using urea, which is one of their most economical choices, they've got a potential for some volatilization, particularly noting the pH. The pH is pretty high. Okay, so if you look at some work that he's done, just looking at volatilization losses of these products, it supports the other work that we've seen with agrotane. Okay, here's volatilization of urea. Here's urea if it's mixed with ammonium sulfate. Obviously, it's going to have less potential. Okay, they're even getting some volatilization of ammonium sulfate here. It's not surprising because they've got ammonium ions in a high pH environment. Okay, ammonium sulfate will volatilize on you in that type of environment. So here's agrotane. Again, put on at the 7-day rate, and if you look at the differences in volatilization, agrotane is doing what they say it's going to do. It's preventing volatilization for a period of time. Eventually, you start to lose it after you get past that window of time. All right, this is nitrogen uptake in the rice. All right, and just to take you through this, okay, this is an untreated control. Took up 105. This is kilos of nitrogen per hectare. It's really close to pounds per acre. It's that would be about 100 pounds per acre. Urea, agrotane, ammonium sulfate, and urea plus ammonium sulfate. Okay, 1, 5, 10 days before they flood. All right, you're not going to have much volatilization potential with 1 day. There's no differences here, right? Okay, at 5 days you've got volatilization potential. Here's your LSD. The numbers that are in red are significantly different than these two. Okay, so you're getting volatilization. Out here you're getting volatilization. Look at the increase. How much more nitrogen we got into the product by using agrotane or ammonium sulfate. Okay, again, just showing that the technology works. All right, grain yield shows the exact same thing. Okay, exact same table. Grain yield, no differences here. You can see some pretty big differences out here, showing that the technology works. Okay, now, that brings us to a study that we started in 2006, looking at Nutrisphere. Okay, they had urea, Nutrisphere at 0.5%, and then Nutrisphere at 1%. Okay, so this is actually is put onto the urea at those rates. 2 different rates of in, 2 different times of flooding. And what he found, first of all, is they had a yield response. Okay, so they're working in a responsive environment. Here's the effective days of flooding. Okay, significant difference here. Okay, there's volatilization occurring. All right, now we look at the yield differences. Here's yield with urea, Nutrisphere, Nutrisphere. Okay, no significant difference. All right. He went out the next year, 2007. Went to 2 different sites, compared urea, Nutrisphere, 3 different rates, 3 different times of flooding. All right, and here's one site, here's the other site. This is showing the nitrogen, the effective nitrogen rate. Okay, so there was a significant nitrogen effect here, and a real big effect at this site, real responsive site. Right? Okay, effect of flooding. Again, you can see there's an effect of flooding. Big difference between this and this, suggesting that you're losing a lot of nitrogen. Okay? You with me there? Hang in there, we're almost done. All right, now here is the differences in Nutrisphere. Okay? No significant difference. Urea versus Nutrisphere. Urea versus Nutrisphere. Okay? So he saw this 3 different sites over 2 years. So then, there's data out there to show that Nutrisphere has caused yield increases in some crops. So he said, well, I'm not seeing a response in rice. Let me take this into the laboratory and let's look at the technology and see if it's doing what they say it's going to do. Okay? He did a volatilization study. All right, and the triangles are urea. Okay, so right here is urea volatilization. Okay, right here is ammonium sulfate. No volatilization. pH was only 6.1, so you wouldn't expect volatilization here. Here's agrotane. Okay, it's holding it up to about 7 days like it's supposed to. Then you get some volatilization. Here's Nutrisphere. Okay? It's not doing anything actually it's significantly different from urea, but it's actually significantly higher. That's not consistent. But what is consistent is he did this 2 more times. got the same result. The nutrisphere followed right on the same line as the urea. Here's another study where he used UAN. Okay? Here we are, urea. Here we are with UAN. UAN should be less. But then right on top of it is UAN plus nutrisphere. Okay? So that's the only data that I can find where volatilization has been evaluated on this product, and this data would suggest that it's not having much of an effect. Okay? You guys are going to get out of here early. I want to cough fast. Summary. I'm just going to summarize these products. If you look at ESN, ESN does provide a slow release of N. Okay? I think there's ample data to show that it does do that. Volatilization is a little concern with this product, which again makes sense because you have just a small amount of urea out there at given time. For pre-plant in corn, ESN appears to have value compared to UAN or urea applied pre-plant. Okay? I think everybody would agree with that. Okay? The one thing that I think is important to know is ESN pre-plant should not replace the standard practice of applying side dress in. Okay? You know, the one situation where if you can go out and put ESN on as a side dress, and, you know, I didn't get to that point either. But if you're side dressing ESN, maybe that's on here. Maybe it's not. If you're putting ESN on side dressing on corn, okay? I think the one thing that we've learned, similar to what I mentioned in wheat, is that when that product is sitting on the soil surface, it breaks down a lot slower than if it's mixed in the soil. Okay? So if you're going to go out and side dress corn with ESN, and I would only do it if I had hot residue, I wouldn't do it on bare soil, unless I was going to field cultivate or row cultivate, which I hadn't seen very many of those. This year I saw 3 or 4 row cultivators, but that's not very common. So anyway, my point is, don't wait too long because it breaks down slow enough, and you go out there when the corn is silky, or later actually, and still see kernels of ESN sitting on the soil surface and haven't broken down yet. Okay? So something to keep in mind with that. And then, okay, so I already said ESN should not be applied to bare soil without incorporating it. Spring top dressings on wheat should contain no more than 30 to 50%. That's generally what I recommend. I'd say in this part of the country, I'd get closer to 30 just based on the data that we collected. And then agrotane, if you look at agrotane reduces urea volatilization. There's ample data. I just pulled out a few studies. There's all kinds of studies in the literature to show that it does reduce volatilization. Broadcasting urea on warm soils should provide the greatest potential for agrotane. If you're going to go out and spread urea on a soil surface, and it's in May, and it looks like it's going to stay dry for a while, I'd say it's probably worth investing in that product in that situation. Remembering that rainfall irrigation eliminates the need for using Eurasian hemorrhage. Okay? Broadcasting UAN on warm soils would provide the second greatest protection. And then dribbling UAN on warm soils appears a question of value. Most of the data that I've seen has shown little value there. Now, there are studies that show that I haven't seen studies that have shown a big benefit from using agrotane in this situation, but there are some studies that show putting nitrogen down in the soil versus dribbling on the surface, you get a benefit. So, you know, we're working on this right now. I think Josh and Bob may be working on that issue too, but it's questionable, I think, still in that type of situation. One thing I would point out, I was talking about nitrogen at a meeting last winter. Well, I didn't even talk about this product, but somebody came up to me afterwards. He was a spinach grower, and he said that he goes out, puts his nitrogen on, and irrigates it right in. And he was thinking about using agrotane in that situation. And, you know, I explained to him what was going on there, but really, there's no reason. You're wasting your money if you're going to get water onto that urea or UAN immediately. There's no reason to purchase that type of product. Okay? Now, I've got the last item down here, the plus part of agrotane. Remember, there's agrotane and then there's agrotane plus. Okay, there's a lot of data showing that agrotane prevents urea volatilization. The plus portion of this product is still not proven to be of a lot of value in my mind. Okay. You know, as I mentioned, there's a lot of work done with nitrification inhibitors back in the 80s. It shows that they work, but we often didn't see a difference in yield at the end of the season. And I think some of that same work here in the east, or some of those same results occurred here on the east. I have been working, we started working with this product, as I showed you wheat data. I didn't show you any data from 2007 in corn. I had 5 sites where we tested agrotane plus, agrotane, and NutriSphere in corn. But every one of those sites was drought stressed, and we didn't have loss potential. I didn't see any differences in any of the products, but I wouldn't expect to see any differences in any of the products if there's no potential for nitrogen loss. Okay? So we have repeated those again this year. Unfortunately, I only have 2 sites this year, and they're both drought stressed. Guys are going to quit letting me work. And then NutriSphere. Okay? NSN appears to have little effect on volatilization. I showed you the data from Rick Norman, and I did just this morning get another set of data that came out of Auburn that showed exactly the same response that Rick Norman found. Urea volatilization, urea with NutriSphere, they're right on top of each other. So it's being duplicated, and being a new product, you know, there's not a lot that's been done, but a lot that's being done right now. There are studies that suggest that you're getting a yield response, okay? That yield response, these data that we're seeing here would suggest that if you are getting a yield response, it's not likely coming from stopping volatilization, okay? But the research database is limited in this region, and we're trying to build on that. As I just pointed out, I just told you I did work in 2006 and didn't see any benefit. Again, the effect on nitrification is something that I haven't seen any data on to show whether or not there is an effect on nitrification. One thing I meant to point out, I don't think I said this at the beginning. I know people like to have handouts of the slides. Unfortunately, the data that I had from Rick Norman is something that he had sent to me over the weekend. It's not published data, and I didn't want to present or hand out those slides until I had his okay. He was in the field the last 2 days. I did get his okay this morning, so I will take this presentation and I will put it on my website at the University of Delaware. If you're interested in going and to get that, I'll have it in a PDF format. How do you get to that website? Instead of trying to give you this big, huge URL, just go to the University of Delaware, which is udel.edu, or you can just go Google University of Delaware. When you get on the University of Delaware homepage, there's a search place for search. In that window, put Binford. The very first thing that'll be on the top of the list is my website. Okay, and I'll put this presentation on there. I won't guarantee it'll be on there tomorrow, but I'll have it on there in the next couple of days. With that, I'll open it up to any questions. Thanks, Barry.
So go ahead and take questions.
What does the ESN cost? I'm sure there's got to be
Yeah, that's a good question. The question is, what does ESN cost? And the standard response that you get if you read in the literature is you're talking about 10% or 10 cents a pound greater than urea. Okay, I call it, you know, one thing about ESN is it's not a lot of places to get it. I don't even know who all sells it, but you know, there are some dealers. There's a lot of dealers in this area that are just set up for liquid, but it doesn't really fit into their system. But you know, so they say it's about 10 cents a pound greater than urea. Now, if you're looking at using it and you're using UAN, you really need to compare it to what it costs to UAN relative to UAN. And you know, I've priced it before, but I'm not sure I'm getting. You know, I'm getting retail prices out there, so it's usually about 10 cents higher than urea. But urea usually, from where I price fertilizers, is usually higher than UAN, so that would make ESN even higher. But it's something you have to look at. I mean, there's a benefit there, but is that benefit worthwhile? And, you know, it's just like any new product. you're looking at a new hybrid or a new soybean variety, I recommend going out there and testing it on your farm. And ESN may be something that may have a fit. You want to test it and take a look and see if you're getting a benefit. Don't go out and start using it instead of side dressing. I think we've got enough data to show that there's enough times when you're going to be going backwards in that situation in terms of best management practice. Any other questions? Yes, sir.
The real issue here, not necessarily the grading yield, but how do we keep nitrogen out of the river streams of the Chesapeake Bay? And which products do farmers use?
All right, the question is, the real issue is, question is, how do we keep nitrogen out of our rivers, lakes, and bays? Which products should people use? That's a very difficult question to answer. And I'm not sure I can stand here today and say that. I mean, you know, looking at the products that, in terms of yield response, what we're seeing here are not big differences in yields. There's data showing ESN doesn't result as much leaching, but that product's not going to fit into a lot of the environment or the management that we use here. So, I mean, I guess the best thing that we can do is to use our best management practices. I mean, using things to fine-tune, putting on, making sure that we're putting on the best rates, or the most optimum rates. So, I mean, those are things that we're trying to constantly improve. But in terms of these products doing that, I don't know that we have any evidence to suggest that one will be better than the other. At least not today. Any other questions? Yes.
Down on the eastern shore, probably in Delaware, there's at least one commercial dealer / applicator that's side dressing a fair amount of corn with urea. And a lot of times it's urea, ammonium sulfate blend, in which are broadcasting it on 16, 10, 12, 15 inch corn. I don't know if they're using any kind of inhibitors or not, but I suspect they may be using something. I guess my question is, since the University of Maryland's guidance is if you're using urea, bump your rate by 25%. Would this apply if they're using inhibitors? Does anybody, in other words, optimize a farmer or regulator looking at someone using it? Do I judge that? Do I look at that?
All right. The question was that in certain parts of the eastern shore, there are dealers, farmers that are side dressing, spinning on urea mixed with ammonium sulfate. And
It's a 50-50 blended material.
okay,
5 pounds of each material alcohol. Not
Right.
equal rates in, but equal rates of product.
right. I didn't know that was being used. I used to work in Pennsylvania some. That's a very common practice to spin on urea, side dressing on corn. And you're saying that the recommendation is to increase the rate. I think that a product like Agricane would have a real value in that situation because you're going to, I mean, it's going to help prevent that volatilization. So I think it would be something that would be worth putting, or at least taking a look at.
Not sure about a clear answer whether I should still be bumping my rate or not.
I would not bump my rate. I mean,
If you do it, that doesn't make a difference. I heard you talking about like nutrition, 0.5% versus the 1%. I'm assuming that's the amount of material. I assume that has some effect, but I don't know what the proper rate was or not.
all right. Expanding on the question is that with Nutrisphere, you're 0.5% or 1%. Is that making a difference? I mean, from the data that's coming out, I think it's questionable whether that's having any effect at all, at least on ammonia volatilization. So I would not recommend using that in this situation that you're talking about. I think Agricane could work in that situation that you're talking about, and I would say you would not need to bump your rate.
So you're saying Agricane would be the product of choice, Nutrisphere would not be the product.
Based on the information that I have seen, Agricane, I have no doubt, prevents volatilization. There's tons of data out there. Nutrisphere, I have yet to see anybody show me that it prevents volatilization. And I've been asking for that data for the last 2 years. It's a Eurasian inhibitor. Please show me the data. I have not seen the data. I have now been supplied with data that suggested it does not prevent volatilization. So I would be real hesitant about using it to prevent volatilization. Any other questions?
Kind of twofold. One is to say that there's been about 5 years of work from state faculty in a very similar where no responsible thing is one out of the time. There's one match with you and everything else is the environment is there. So with the ESN, is there anything that you've done that you can see that you can actually reduce the rate applied at any given time if you use ESN over urea or over UAN and anything?
I gotta repeat that question. In Oklahoma, he says that with winter wheat, that there's been work done with agritane that shows maybe 1 year out of 5, one situation out of 5 where you'll get a benefit from it. And then the question about ESN, say it again.
Have you done anything where you can have tested if you can reduce the rate applied?
Okay, the question is, have we done anything with ESN to suggest that we can reduce the rate applied? And I would say no, I have not. Because of the size of each studies, I haven't been going and doing the whole rate response for each product. Generally, the recommendation that Agrian has, and they have a pretty big database, would suggest that you are more efficient, so it does take a little less nitrogen. But I don't know if we're at that point to say that you should actually reduce the rate. And you bring up a point that I think is very important that I did not point out. Well, I kind of did, but not directly. And he's talking about agritane in wheat. And that's the other thing you got to keep in mind when you look at that product. In the situation that you're talking about, Howard, you're talking about warm soils where you have a tremendous volatilization potential. When we're putting nitrogen on in winter wheat, we don't have nearly the volatilization potential. Okay? So, and quite often, I mean, I've tried it for 2 years now, and we're trying to get that nitrogen on in between rainfall on that winter wheat in March. That's not a situation where I don't think you need to put on agritane if you're just trying to squeeze it in between rainfalls. You're going out on cool soils. Your probability of a response is greatly reduced. In your situation, though, however, I'd say you got a much higher volatilization potential. And I think the potential there for value is much greater. Other questions?
Any other questions?
Yes, sir.
Well, when you did the study for that thing, you used ammonium sulfate. Did you consider the sulfate and the sulfur part of that equation? And when you did the other study as far as keeping the yields up?
Yeah, the question was when I did studies with ammonium sulfate and putting on different rates, did we take into account different rates of sulfur? And the answer to that is yes. When I would make a blend that would, we would actually, when we put on different rates, we'd actually be putting on the same amount of sulfur. Okay, and that's how we first started doing the studies. It was a pain. That's why I switched to using ammonium nitrate, just so I didn't have to worry about that sulfur response. But ammonium sulfate, I mean, that's something that is very commonly used in wheat, though, and makes a nice blend. I mean, matter of fact, I know some places where they are using ESN, they're blending it with ammonium sulfate and urea. But anyway, yes, I did take that into account. Other questions?
There's no more questions?